You'll have a chance to hear from Jeff and Emily a little later in the webinar, but now I'd like to turn it over to our first speaker, Patsy Root. Patsy?
Hey, Glenn, thank you so much, and welcome everybody to the webinar. We're glad to have you here. So the webinar is going to talk about a refresh to culture controls, but I thought before we get into the specifics, it might behoove us to talk a little bit higher level about quality in general. So when we think of quality in the laboratory, or any other organization actually, there are several parts that make the whole relationship of quality work. And you can see on the right-hand side, the largest part is the quality system. And then we have quality assurance. And then in the smaller circle, you see quality control. So the first thing that I want to talk about a little bit is the whole quality system, which is technically how you manage your company, how you define your policies, how you define your objectives and the principles, and who's responsible for the activities within the company. The quality system really does ensure that you have a good structure and everybody understands their roles. But it also includes a bunch of other things. Quality system should probably include how you manage your data, how you manage your purchasing. And it should also, very importantly, address continuous improvement, which means having a corrective and preventative action plan for when things don't necessarily go the way that you have planned them to go. Your quality system should also include not only employee training, but also engagement of your employees and how you manage the quality of your suppliers. So there's a lot that's included within the quality system itself that really helps a company for its customers and for the public, how they are running their company. So quality assurance and quality control, I find often get a little bit mixed up and sometimes used interchangeably. So let's talk about those individually. Go to the next slide. So we have quality assurance on the left and quality control on the right. And the biggest differentiator between quality assurance and quality control is that QA, quality assurance, is actually a design of the process, how you are going to address quality. I might do it by documenting what I do, by having standard operating procedures or SOPs. But basically what quality assurance does is it leads to reliable, robust data every time the process is followed. So quality assurance will define the responsibilities of everybody in the organization, like who's the QA person that will sign off on batch records. It also is about establishing acceptance criteria. If the data meet certain acceptance criteria, then they meet the customer's requirements as well, typically. Also, again, quality assurance is involved in the continuous improvement process because, as we'll talk about in a second, quality control falls under quality assurance. And it's also important that you have a quality manual, whether it's hard copy or electronic copy, so that everyone in the organization has the ability to view what's included in the processes to achieve quality assurance. So quality control, the very smallest circle in the Venn diagram we looked at a couple of slides ago, is also equally important and vital to laboratories, but it really is reactive. And the existence of quality control is to identify defects in the processes after it's happened. So let your brain wrap around that for a while. QC is reactive, and it helps you identify defects when they happen. So, for example, we're checking the temperature of an incubator. supposed to be at 35 plus or minus 0.5. We find it's at 32. The incubators failed. That's happened. Now, the why it failed and how we fix it falls under quality assurance. Recalibrating your balances is part of the quality control that your laboratory or your utility laboratory does on a daily basis or a routine basis. Checking the sterility of sample bottles, because if that fails, we know that the sample taken with that bottle is not going to be correct. Another activity that's associated with quality control is checking the accuracy and precision of your pipetters, standardizing your pH meter. But today, what we're specifically going to talk about is checking the performance of the media with positive and negative culture controls. Because in microbiology, it is the most important thing to make sure that your media is performing the way that it should be so that when you get results, they are reliable and robust and meet all of the quality assurance check marks that it has to meet. So let's talk a little bit in the next slide about positive and negative culture controls. So these serve a variety of functions. But at a basic level, what you want to make sure that you and your laboratory personnel understand is that these are organisms that help you demonstrate that your media either will find the correct target or will not detect a non-target. So, a positive control makes sure that your media is picking up what it's supposed to pick up. Right? So if you're using Colert on the top here, and you want to be able to pick up total coliforms, then if you use a positive organism, say an E. coli strain, then you should get the result on the left. It should turn yellow and be more yellow than the comparator. And if you're using an E. coli, which will be a total coliform and obviously E. coli, then at the bottom here, it should be yellow and also fluoresce. But the thing about positive controls is in a typical, say, drinking water sample, you should have 0 present. So when you're challenging and checking a positive control in your media, you want to make sure that you demonstrate your media can pick up the targets, but at a very low number. So, like for instance, the IDEX method here, Colert and all the other ones, can detect a single organism in 100 mils of water. So when you use a positive control, you're not only checking and proving that you can find the target, but at very low levels. And the opposite is true with a negative control. So with a negative control, you want to make sure that your media isn't picking up non-target organisms. So when you do this, it's much more appropriate to use a very high number of organisms when you are testing for a non-detect. And actually, usually with the IDEX reagents, you can have up to about 2 million non-targets in the 100 mils. And still not confound the test. You'll still get a correct answer. So typically, again, with a positive control, you would have a very low concentration to check your media. But then with a negative control, you would have a very high. And I also want to point out here that there's nothing that says blanks on here, because a blank is something very different. And it serves a very different purpose. You do not use a blank as a negative control, just to be very clear on that. So next we're going to talk about 4 things. We're going to talk about examples of quality control procedures that require culture controls. We're going to talk about media checks, method QC, demonstration of capability, and everyone's favorite, proficiency testing. So first, let's talk about media checks. Any of you that are ISO 17025 accredited in your lab, or if your state utilizes the TNI standard, or even a certification process, you're familiar with the fact that every new batch or lot of media has to be checked for performance and sterility, all right? So it's important to understand this because you want to ensure that the media has not changed over time and it will still find what it's supposed to find, not find what it's not supposed to find. And this is typically done by using a positive culture strain plus sterile water plus the media, and you incubate it as any other normal sample, and then you read the results. And then with a negative culture strain, you would add that plus your sterile water plus the media like Kohler, incubate that per your standard SOP, and record the results. With the negative culture strain, you should not see any typical colonies or color change or fluorescence or anything like that. Both of these are important to prove to yourself, your QA group, and to your customers, internal or external, that the media has not changed over time. And when I say batch or lot, I know I've put both in there, but typically a batch is something that's prepared in the laboratory, you know, like a batch of MFC media or something like that. When I say lot, that's typically something you would purchase, like Kohler 18. I just wasn't sure if anybody was following along with my thought process and how those two words are used. The other thing I want to point out about media checks is that please never, and this is in the TNI Volume 1, Module 5, use media, whether it's media made by yourself or purchase. Never use it past the expiration date, okay? That should be in your SOP. And also make sure that you document your entire process, including detailed testing criteria in your SOP. And sometimes I have seen, and I find this very efficient, is that the laboratory's SOP, when you're doing a media check, actually has places you can fill in, and then the copy of the SOP actually becomes a record. That can be really helpful for laboratory technicians. So the next thing we had out of the 4 was method quality control. So this is the QC that determines how the method performs, and it's typically done before you adopt a new method into the laboratory. So say you were using ISO 11131 to test for Legionella, and then now you're going to start using Leech Alert to test for Legionella pneumophila. You should always do quality control for the method to ensure that you are getting the results that you should be getting with that methodology. So when you're choosing a new method to bring into your laboratory, you first want to make sure that if this is compliance testing, that the method you're looking at is contained in the rule and it's allowed. And when you see that the method is allowed, say by EPA or any other regulatory agency, they'll list the method, and very often there will be a little number or letter to indicate there's a footnote. If you are in the US and you are following an EPA approved method, ensure that you do what the footnotes say, because the footnotes are promulgated as well, which means they are also part of the rule. So if it says something in the footnote that you must do, but it's not in the method, you still have to do it. Other places that you can look at for QC related information to help you figure out what you should be doing for quality control with a particular method is also within the standards themselves. So most of you are probably familiar with standard methods for the examination of water and wastewater. Huge compendia of methods. Chapter 9000 is where all the microbiology methods are included. When you follow a method in standard methods, say 9223, which is where the IDEX methods are, Kohler 18, and Kohler, it has QC within that specific section of 9223. But you are also required to follow all additional QC that's listed in Part 9020, because Part 9020 is the overarching quality control portion for the whole chapter. So make sure you reference that. If you're a state that follows the TNI standard for accreditation, ensure you understand Volume 1, Module 5. If you follow ISO 17025, make sure you look at the QC requirements of all of your methods and anything associated with 17025. So the quality control is dependent on the method you choose. So make sure you pay attention to where you choose your method and the additional information that be listed there, because some of the things that you may have to do would be obviously sterility. You have to, everything that's going to touch the sample in micro has to be sterile. You may have to do demonstrations of capability. You might have to do counting variability, temperature checks, duplicates, which is not all methods. You may have to do method blanks, but not with all methods. And also you may have to run positive and negative culture controls for every batch, which is not also required for every single method. So understanding all of the QC requirements for the method, depending on where you got your method from, is really important. So the last thing, not the last thing, I lied. Next to last thing is demonstration of capability. So anybody that's going to do a method in the lab, any of the bench analysts, has to demonstrate that they can perform the method as written, following the standard operating procedure, however written. So that has to be done for every single analyst or technician, regardless of their experience, when bringing in a new method. And then after the method has been in the laboratory for a while, then the analysts and technicians do a periodic ongoing demonstration of capability. So it's really important that you have good quality culture controls in order to be able to assess whether an analyst or technician can perform the method, including all the QC, before bringing any new method into the lab, and then on a periodic basis as well. So be written in your quality manual how often they have to perform a demonstration of capability other than the very first time. What they have to do is they have to analyze at least one positive sample with a known count. So in order to create that sample in the laboratory, you would have to use a known culture, positives and perhaps negatives, and put them in a sample matrix, incubate them, and then have the analyst read them. For ongoing demonstration of capability, this can also include like your daily or periodic batch of QC. And then the how, I think we probably covered that pretty well. Proficiency testing is the last thing we're going to cover. And proficiency testing is everyone's favorite. This proves to yourself, your customers, and the public that your laboratory can perform the method as written, and you get compared to a whole bunch of other people in a bunch of different laboratories. The accreditation bodies require 1 a year. Unless you are in a TNI state, then you have to do 2 per year. And it ensures, like I said, that the laboratories are capable of accurately performing tests. They are independent of the PT providers and conduct the PT program and analyze the data. And the results typically go to directly to the state or the province. So with QC, it can be really helpful if you know what the format of your culture controls or your QCs. And what's important to consider is looking at your culture controls for your QC that are as similar as possible to your proficiency testing. So I want to be really clear, because if you are a customer of IDEX, you probably know that you can buy culture controls from IDEX, but you can also participate in NSI's PT program. But I just want to be clear that, we simply accept the order and that the NSI team is going to process and do all of the activities associated with the PT. So we do not have any visibility into those studies. We just are offering those. So when you get your quality control samples from us, they are going to look very much like the PT that you would get from NSI. So having that similar format makes it a little bit easier for the analyst because it's a familiar platform. But I just wanted to be clear that we don't have any visibility into the PT program itself. That allows us that independence and non-bias relationship there. So we've gone over these 4 ways that you should be using culture controls. And what I'm going to do at this point is I'm going to turn it over to Jeff to give you more detailed information. Jeff?
Thanks very much, Patsy. So Patsy just gave a great introduction to what positive and negative controls are and when water microbiology laboratories need to use them. Just before I dive into the different options, I know that many of you are familiar with Patsy and her expertise, but for those of you who don't, I just wanted to call out something that you may have missed on her slides. This is something that Patsy is likely too humble to call out herself, but I'm in marketing, so it's my job to do this. On one of Patsy's slides, there was a reference to a paper from 2014. You wouldn't have seen it on the slide, but the title of the paper is Microbiological Water Methods, Quality Control Measures for Federal Clean Water Act and Safe Drinking Water Act Regulatory Compliance. And Patsy was the lead author of that paper. So I just wanted to highlight really the depth of Patsy's experience on the subject and that we're lucky to have Patsy on the webinar today. And because of Patsy, we now have a great background on positive and negative culture controls and when to use them. So in this section, I will be discussing what materials are available for performing these positive and negative culture controls. And of course, I'll say up front that I don't have even close to the depth of expertise that Patsy has on the subject. So all of the content in this section is really based off of observations of QC practices in water microbiology laboratories, or conversations with laboratory managers and staff, as well as laboratory auditors. So one way to think of this content is it's really describing how your peer laboratories are using these QC checks, and we hope that's a helpful framework to use. We hope it's helpful to see what your peers are doing to meet these requirements that Patsy just went over. Here we go. Great. So this actually echoes a lot of what Patsy was just saying. This first option that I want to highlight, and this is because of the benefits that Patsy mentioned. This is a very commonly used option, is to purchase positive and negative culture controls from their PT provider. In most cases, this is the format of this is a lyophilized pellet, so it's just a dried pellet. You'll see what it looks like in a video that we have in the next section. But the pellet contains specific strains of bacteria that are needed to perform these controls. I do want to highlight that there are some vendors that sell these controls in a different format. At least one vendor actually sells a ready-to-use liquid. But no matter what, just to reiterate what Patsy mentioned, the benefit of using the same vendor for your PT and your culture controls is that regardless of the format, you'll be using the same vendor and the same format for both PTs and culture controls. They're going to be delivered in the same format. And I think as Patsy alluded to, this really just helps reduce the opportunities for error when you're performing your truly all-important PT. If the procedure to perform your media checks and the procedure to perform your PTs are the same, then really every time that you or your laboratory analysts do a media check, then it's like a practice run for a PT. So that's a real benefit that a lot of laboratories take advantage of. There are a lot of other benefits of using the same material for media checks or other QC and PT. In general, from all of these vendors or the vendors that we're familiar with, you're going to receive a kit that has exactly the strains that you need to use. So just as an example, if you need to do a method check on Colert, If you're purchasing from a PT provider, you're generally going to receive at a minimum 2 positive controls, one that is a total coliform positive, but not an E. coli positive, and one that is an E. coli positive and total coliform positive. And then also a negative control of a non-target bacteria, as Patsy explained. So that's another benefit. In general, I'd say there's limited drawbacks to using a culture control from a PT provider. Of course, some of these options are more expensive than others. And then I think the only other thing to mention is that if you use the liquid ready-to-use option, then those are going to have expiration dating that's shorter than a lyophilized pellet would be. So you just need to make the trade-off between the ease of use of the liquid version and ensuring that you have the materials on site that haven't expired when it comes time to do a media check or whatever other control you're doing with a culture control. Again, just to summarize this, in general, using the same provider for your proficiency testing and the positive and negative culture controls, it's a popular approach with a lot of benefits. So another option that we wanted to highlight is generally in a similar format, so that lyophilized pellet or disc, but we refer to them as bulk format options because they're a little bit different from what you would get from a PT provider. First, these vendors are generally not just selling to water microbiology laboratories; they're selling into food microbiology, pharmaceutical applications. So they have generally huge catalogs of hundreds of different strains. They do sell the strains that can be used in water microbiology. But if you're going with one of these vendors, you are going to need to peruse the catalog to find the right strain. They're generally not sold in a kit of what you would need to do a media check on a reagent, for example. It's important to find the right strain. You can't, if you're looking at one of these catalogs, you can't just choose any E. coli strain for a positive control, as different strains will behave differently in any water microbiology test. So in the US, we're not as stringent as in Europe in terms of making sure a specific exact strain is being used, but it's very important to choose a strain that's intended to be used in water microbiology so you get the right results. And in a lot of the materials that Patsy referenced, and thinking TNI standard methods and the EPA Manual for Certification of Drinking Water Laboratories, there are examples listed. The other thing to consider here is that each strain is sold in a pack of generally at least 6, but pack sizes can go up to 20. So if you're including positive and negative culture controls with each batch of samples, that might make sense. You may go through that actually relatively quickly. But if the only culture control that you need to run in a year is a media check with every new lot of co-alert, and you're only getting 2 to 3 lots of co-alert a year, then some of these materials might expire and might need to be discarded. So just some considerations there. Another option that's used by a lot of water microbiology laboratories are what we would refer to as culture sticks or controls that have built-in swabs. These come in a plastic tube. They contain a lyophilized pellet, just like many of the other options. But also included in the plastic tube is an ampule of rehydration buffer, as well as a swab. And the way that these work is that to use them, you break the ampule and the buffer flows into the part of the plastic tube that has the pellet. I'll show a little bit more what it looks like on the subsequent slide. But then you mix the buffer and the pellet together into a slurry with the swab. And the idea is that from there you can easily streak a plate to create a working culture. We'll discuss that in more detail in just 2 slides. But this is a fairly popular option. There are a few considerations to note here. Similar to the bulk format controls that we just talked about, these controls are sold by organism. So again, it's important to find the right strain. Emily will go into more detail on this in her section, but these solutions also create a fair amount of waste, including this bacterial slurry that you just made that you need to deal with. And also these controls can only be used for presence-absence testing, which works perfectly well for a lot of laboratories, especially drinking water laboratories in the US, but that is also an important thing to note. So just wanted to provide a little bit more detail on these on this option. So this picture here shows how these culture sticks or controls with built-in swabs work. You can see the plastic piece that the analyst is holding in his lower hand here. That contains the slurry of the pellet and the rehydration buffer, and then the swab is in his other hand. So this all comes sort of as one unit to the laboratory, and then they're separated by the analyst. And you can see at the end of the swab there's a little bit of slurry on that. Traditionally, and according to the product documentation of these products, you would streak that onto a plate. However, in this example, and this is popular, this is done fairly often, you can see that the analyst is going to directly inoculate this sterile water in front of him with the swab. And so again, this is fairly common. Many water microbiology laboratories, instead of inoculating a plate, are going to just put the swab directly into 100 mils of water, and then add the colort or whatever reagent, and simply perform their QC that way. So just a couple of things to note. I will say we've tested that approach in the laboratory, and it's definitely robust and effective. It produces the expected reactions. So it's certainly a good way to perform these controls. It works, produces the right results. It is important to consider how this approach adds some additional process steps that you don't have to perform if you're just dropping a lyophilized pellet into sterile water. And we'll show how that's done in a video in a few slides here. Additionally, you can see that when this analyst needs to close the vessel after the sterile water has been inoculated, they're going to have to do something with this little plastic container that contains this slurry of bacteria. So there's a risk of spillage and contamination that really isn't present when you're using a pellet alone. So again, wanted to call this out because it's a popular option. It is a pretty innovative design, and they're certainly kind of fun to use when you break the ampule. But as I mentioned, there's a few things to consider when using them versus using other culture control options. The last option I wanted to highlight, we see this used on a fairly regular basis, is to grow and maintain cultures in-house. So what you're seeing on the screen here is just one example of how this is done. But the idea is that you have an input strain that you reproduce and grow in the laboratory for ongoing use, using an agar plate, an agar slant, or a broth, just some sort of growth medium. As I mentioned, I'm not a microbiologist, and it would really be beyond the scope of this webinar to show you the proper technique here. Again, this graphic is just one example of how in-house cultures are maintained, but I did want to highlight a couple of key items here. So first, and we touched on this earlier, but the choice of the input strain is important. Oftentimes, the input strain will be a reference culture from a type culture collection. So in the US, the most commonly known type culture collection is the American Type Culture Collection, or ATCC. That said, there are type culture collections all around the world, so there's other options, though if you're in the US, ATCC is probably most convenient. That said, it's also important to highlight that your laboratory does not need to utilize a reference culture, for example, from ATCC, as an input strain. You can utilize any of the other examples that I went through as an input strain. As I mentioned, the culture stick options are designed for this purpose, to incubate a plate or a slant or broth. It is important to note, just one thing to highlight here is that you shouldn't perform more than 5 passages or subcultures from the original reference culture. And again, too much detail to go into here, but if you're not familiar with the concept of passages, the ATCC has a great technical document on this, and it's linked in the resources if this is relevant to you. So again, this is a fairly commonly used option. wanted to, along with all the other ones, wanted to touch on the pros and cons. One of the pros is that the approach, of course, can be cost effective. You're essentially getting more uses out of a single input material. So you only need to purchase the first input material. Emily will go into more detail in her section about when it makes sense to maintain cultures versus purchasing commercial options. But I would say the major drawback here is that it takes time, and it really should be performed by a trained microbiologist. Of course, trained microbiologists always have a lot of demands on their time, so it's always worth considering if it makes sense to trade off budget to free up their time, especially if you only need to use these culture controls once every so often. And so again, Emily will go into more detail in that on the following section. Just one final thing to note: if you're maintaining your own cultures, it's certainly more difficult to do quantitative testing. It's possible with a lot of dilutions, but it's more laborious and difficult to perform than simply maintaining the cultures. So certainly beyond the scope of this webinar. So just to quickly wrap up here, of course, there are other options for these positive and negative culture controls, but the ones that I've just highlighted are really the most popular options that we see being used in water microbiology laboratories. And yeah, hopefully this has been a helpful review, that it's been worthwhile to see what else is out there. We know it's fairly rare to change these methods from what's always been done. So yeah, hopefully useful to see what else is possible. So with that, I will pass it over to Emily, who will go into detail on a specific option for positive and negative culture controls, which is IDEX QC.
Thanks a lot, Jeff. That was a great overview. I'm going to wrap us up here by just talking about IDEX QC, which is IDEX's version of that kind of one-shot culture. We do offer these in a full suite of tests that are designed to be used with all of IDEX's reagents. Now, these kits are derived from ATCC or NCTC strains. They are ISO 17034 certified, and they're produced in a laboratory accredited to ISO 17025. So really, really important when it comes to quality. Now, the IDEX QC kits, they're in a really easy to use format, and I'm going to show you a video of how those are run in just a moment. The materials are quantified with a target MPN and an acceptance range. So it's a big difference between IDEX QC and some of the other options that we've talked about today, is that these are quantified for you. So we've done that work for you. Each kit comes with at least one positive control. In the example of a total coliform and E. coli kit, it would come again with a one positive control for total coliform, one positive control for your E. coli, and then also your negative control. These all come in replicates of 3, which means that each one of these kits can be used for 3 unique QC checks, which has been really popular with the users. Now, each of these kits has a shelf life of at least 12 months from date of manufacture. Some of the kits actually go all the way up to 18 months from date of manufacture. So that's really nice, especially compared to those full liquid options. We've talked a lot about this, and I'm going to talk about it a little bit more at the end of my section, but it can be paired with proficiency testing. So there's proficiency testing produced by the same vendor. And last but not least, the glass vials and the paper boxes that these come in are very easily recyclable. Now I'm going to just take a quick moment here and show you that video so you can see IDEX QC in action.
IDEX QC kits offer a complete suite of microbiological QC solutions, providing easy-to-use QC kits for each of your IDEX reagents. Remove the vials from the freezer and let them sit at room temperature for 15 minutes. You will need one of each type of organism from the kit. For example, the IDEX QC Total Coliform and E. coli kits contain 3 different QC organisms. Open the vial containing your QC organism and transfer the pellet to an appropriately labeled sterile vessel filled with 100 milliliters of sterile water. Shake the QC sample and allow it to stand for approximately 5 minutes or until the pellet has completely dissolved. Once the pellet has dissolved, mix the sample by inverting the vessel 10 times and use within 30 minutes of hydration. Repeat these steps for each QC strain. Now that the QC samples are prepared, they are ready for use with the appropriate IDEX reagent. Quality control can be run as a presence-absence or quantification using an IDEX quantitray. Select the appropriate quantitray based on the acceptance ranges for each of the organisms in the IDEX QC kit. Acceptance ranges for each lot of IDEX QC can be found on the Certificate of Analysis at idex.com/water.
Great. So now you guys have had a chance to see how easy that is to prepare and maintain. Let's take a look and see how it compares to some of the other options that we've talked about today. First, again, we are taking work off of your plate by quantifying it for you. You could see an example of what the quality certificate looks like that provides the target MPN, but also the acceptance range, because we know that there's going to be a range when this goes out into the field. The ranges that we talked about, they're actually something you can really depend on because they're set with IDEX reagents. And that's not something that you can say with all of your QC kits because it depends on what products they're using to actually set those ranges. With IDEX QC, IDEX products are being used at multiple different locations in order to set those ranges. So it's definitely data you can be confident in. We've also paired with proficiency testing, and I'm going to talk about that more in a minute, so I won't go into too much detail here. These strains can actually be used as an input for your in-house cultures. And Jeff talked about that a little bit at the end of his section, and I'll go into more details on why that might be an option for you. And lastly, each of these kits comes with very recyclable packaging. And that's a big difference compared to some of the other products that we have talked about today. What does an example of that waste look like, you say? Well, here is an example of what one strain for IDEX QC on the left-hand side and one strain using one of those culture sticks, the built-in swabs, would look like. So obviously you can see there's a glass vial and some very small bits that are not easily recyclable compared to your culture stick, where you've got the multi-layer foil. You've got the actual swab itself, which in a lot of cases is considered a biohazard because you've now just mixed that slurry inside of it. And then that plastic tube that it comes in is actually a pretty considerable amount of plastic. Now, jumping back to those in-house cultures, I want to explore that a little bit more. So if you're doing daily or weekly QC, we recognize that purchasing one of these one-shot QC options may be cost prohibitive. However, you can use IDEX QC to maintain your own in-house cultures. And we do have an SOP for that process if you're interested, so please reach out to us if that's something that you'd like to look into. Now, if you're doing monthly or quarterly QC, there's some other considerations that you might want to look into. I think the one-shot options are definitely more beneficial for these laboratories. First, Jeff mentioned this, but if you have a trained microbiologist that's maintaining your in-house cultures, what else could they be doing with that time? So I want to challenge you all to think about that opportunity cost that is often lost when we're looking at these types of evaluations. Now, if you don't have a highly trained microbiologist maintaining these cultures, or there's a team of people that are maintaining them, now I want you guys to consider the challenge of what could happen if there's an error to that process and what that risk looks like. So those are just some things that not everybody thinks about when they're talking about their QC that I think you should consider moving forward. Now, the last thing I want to talk about here today is just coordinating your PT and your QC. Now, both Patsy and Jeff talked about this a little bit, but I do want to walk you through kind of that process. And it's a lot of questions that we get about having your QC and your PT being ordered from the same company. So first, the PT programs are in the same format as the QC kit because they're manufactured by the same person. Second, while we've done a lot to make ordering them more convenient for you, I do want to say that the PT services are offered purely from a third party. IDEX does not take part in that, which actually maintains the integrity of your PT results. So once IDEX takes the order for your PT, we forward it on to NSI. NSI is then going to manage everything from there. So IDEX has no part in stocking or shipping the PT programs, and we have no part of the results generation or the reporting out of those results at the end of that. So just because you place your order through us, we have no part after that. Now, I think that partnership that we have with NSI has really improved the process for a lot of labs, and we do a very nice job at maintaining that integrity of that process because we know how critical it is to everything that you guys do. Now, with that, I'd like to take the next few minutes to invite Jeff and Patsy back on to the screen so we can answer the questions that you guys have submitted throughout this presentation.
Fantastic. So I will, these have been great questions coming in. Thank you all for asking them. We will certainly not be able to get to all of them today, but I'm going to try and go rapid fire so that we can get to as many of them as possible. So the first one, which I think probably is a question for Patsy. Can PT analyses be used as continuing demonstrations of capability? Can you talk a little bit about that?
You can, as long as that's how your documentation is written for how demonstrations of capability can be performed.
Great. And I think this is probably to you as well, Patsy, but there was a question about if there are certain methods that identify certain ATCC strains or WDCM strains, and the question was, does that exact strain need to be used, or can you use the same organism? So I think there's a little nuance there that I was hoping you could unpack.
Yeah. So if you are an ISO 17025 laboratory in Europe and you are following an ISO method, such as ISO 9308-2, which is Colard 18. Another ISO standard, ISO 11133, states which strains of bacteria are to be used for QC. So you followed that, right? But here in the US, the EPA's lab certification manual lists some suggested strains that you can use for QC. For microbial testing. It is not an exhaustive list, nor it is so that you can use those or others. So there's no reason you can't use a credible, strain from a credible CRM, certified reference material laboratory, an ISO 17043 accredited facility. So the answer is, if you're in Europe or other places around the world, the strain designation is that, and you will use that. Here in the United States and in Canada, you don't need to. You can use any strain that is certified.
Right.
Did that
right. Really important?
You think that answered the question, Jeff?
Exactly. Yeah, I think it's important to look at which document or which standard you're being certified or evaluated against, and just look very clearly as to whether or not it's you shall use this strain or here are some example strains. And I think, in general, it does differ geographically.
Where you source your method is important.
Yep. Great. So question about IDEX QC. Emily, can you? Is there a target temperature for the actual sterile water that you're transferring that pellet into, the IDEX QC pellet?
Yeah, absolutely. Part of the part of the procedure is that the pellets themselves actually come to room temperature from frozen, and likewise, we would want the water that they're going into to also be room temperature. A little happier environment for the bugs.
Great. Yeah. And I guess a similar, just in the couple of seconds that we have, similar question is, I think there's always some question about, can that be sterile water, or does that need to be a buffer, just in terms of being a happy environment for bacteria? You can just touch on that.
Yeah, we do recommend using sterile water with IDEX QC, especially if it's going to be used with IDEX reagents. IDEX reagents are going to buffer that product for you.
Perfect.